Bismillahirrahmanirrahim. Assalamu alaikum, student. Today I will say level past paper 3 May June 2023. Before starting the paper, please subscribe my channel and press the bell icon button. Let's start the paper. Question number 1. Solve the inequalities 5x minus 3 less than 2 into 3x minus 7. This question can be solved easily if we take pair on both sides. Because when we take pair of the absolute value, we do not need to know about the sign of the absolute value. Now the square of 5x minus 3, we use the identity a minus b whole square. That's equal to a square plus b square minus 2 times of ab. Now the 5x minus 3 whole square becomes 25x square plus 3 square is 9 minus 2 times of 5x into 3x less than, and 2 square is 4, and the square of 3x minus 7 will become square of 3x become 9x square plus 7 square become 49 minus 2 times of 3x into 7. You see here that's become 25x square plus 9 minus 30x minus 30x less than 4 times 9 is 36. 36x square plus 4 times 49 is 196 minus 2 times 3 6, 6 times 7 is 42. 42 times 4 is 168. Now we can write it as 25x square minus 36x square minus 30x, and that value is minus 168x. Now when we shift from right to left side, that become plus 168x, and plus 9 is written as it is. Plus 196 shift from right to left become negative 196 less than 0. Now we simplify it. 25 minus 36x square become minus 11x square, and minus 30 plus 168 is plus 138x plus 9 minus 196. That's value become 187 and less than 0. We divide this by negative 1. Divided by negative 1, that inequality become plus 11x square minus 138x plus 187, and the direction of inequality, it would be changed because when we divide the inequality by negative, we write it as from less than to greater than. Now 0 is written as it is. Now you see here, this is the quadratic expression. You can solve it by midterm breaking or by using the quadratic formula. Now you see here, when we multiply 11 multiply 187, now you see here we can write it that is 11 times 17 is 187, and 11 is written as it is. Now 11 11s are 121 and 121 17. You see here, if we take the factor 121 into 17, when we add these two values, the answer becomes 138. Therefore, we write it as 11x squared minus 121x minus 17x. When we add these numbers, we get 138. And plus 187 is written as it is, greater than 0. Now we take the common. Here 11x is taken as a common. That value become x minus 11, and we take the common minus 17, you get x minus 11 and greater than 0. Now you can write it as 11x minus 17 into x minus 11 greater than 0. Value of the inequality can be found by using the graph. Now you see here, this is the quadratic expression. Now we draw the graph of this quadratic expression. You see here the value of x will be equal to 17 over 11, and this value is equal to 11. Now we at 17 11 over 11 is equal to 1.55. We mark this value, intersect the x-axis at point 11 and 1.55. Now you see here the values of y greater than 0, all these values greater than 0. And you see here these values on the graph will be greater than 0. I mark with the red crosses. You see here when the value of x is less than 1.55, yeah, you can say the value of x is less than 17 over 11. Their value will be greater than 0. Now, in the next, you see here the value of x when it's greater than 11, the value on this graph, you see here will be positive. Now, these are the points. It shows that the values will be positive. Now, therefore, x will be greater than 11 and less than 17 over 11. This inequality will be greater than 0. Now, this is the answer. Question number 2, solve the equation ln 2x square minus 3 equal to 2 ln x minus ln 2, giving your answer in exact form. Firstly, we write the left-hand side ln 2x square minus 3. We use the logarithm rule, a ln x equal to ln x power a. Now, according to this rule, the 2 ln x become ln x power 2. The coefficient of ln becomes the power. Now, minus ln 2 is written as it is. Now, in the next step, we write the ln 2x square minus 3 is written as it is. Ln x square minus ln 2, use again the rule of logarithm, ln a minus ln b is equal to ln a over b. We use this rule here. And you see here ln x square minus ln 2, it becomes ln x square over 2. Now, taking anti-log on both sides, we get ln 2x square minus 3 equal to x square over 2. You can write taking anti-log on both sides. We multiply by 2 this equation, we get 4x square minus 6 equal to x square over 2 multiplied by 2. Multiply by 2 on both sides. Now you see here 2 will be cancelled. That value become 4x square minus x square equal to minus 6. Shift from left to right side become positive. Therefore, 3x square equal to 6 and x square will be equal to 6 over 3. That's equal to 2. And we can write it as x square equal to 2. And therefore, taking square on both sides, the x will be equal to plus minus square root of 2. Now you see here we have to find the value of x. Now the value of x here are plus square root of 2 and minus square root of 2, but the ln minus square root of 2 is not possible. Therefore, x equal to plus square root of 2 will be the answer. Question number 3, part A. On an Argand diagram, sketch the locus of point representing complex numbers z satisfying z plus 3 minus 2i equal to 2. Firstly, we write this equation as set, take the common minus 3, that value become minus 3 plus 2i, that will be equal to 2. Now, if we suppose that minus 3 plus 2i equal to z0. Now we can write this equation. This is the value 2, and we suppose that r equal to 2, and therefore we can write it as z minus z0 equal to 2, and it This equation represents the equation of circle. In this equation, this is the radius of circle, and z dot a minus 3 plus 2i, this point shows the center of circle. Now we can write it as center equal to minus 3 2. This is the center of circle. Now we will draw it on a complex plane. Now firstly we draw the complex plane. This is y-axis and this is x-axis. The y-axis is called imaginary axis and x-axis is called real axis. We mark the point here 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3. Now we will mark the center, that is minus 3, 2, and this is the minus 3, 2. This point is minus 3, 2. And you see here, the radius is 2. Therefore, we draw our circle of radius 2. Now, this is the circle having the center minus 3, 2. The radius is 2. This is the 2 units radius. And this is the Argand diagram of the equation z plus 3 minus 2i equal to 2. And now we move the next part of this question. Part B, find the least value of z for the point on this locus, giving your answer in exact form. To find the least value of z, we will draw a line from origin to and passing through the center, and it cuts the circle at 2 points. We name it this point z1, and this point is z2, and this point z is the minimum value of the locus. Now we write it as z1 will be equal to OC minus r. This is the least value, and least value of z, you can write it as z least value. Now you see here, we can find the length OC by using the Pythagoras theorem. You see here the OCD, this is the right angle triangle. Now we draw separately this right angle triangle here, and the base of this length you see here, this is the length 3 centimeter units, and this length is we name it as suppose D, and CD length is 2. You see here, this is the 2 unit upward, and we have to find this length OC. Now the OCs will be equal to base square. Base is 3 square and altitude is 2 square. We write it as 2 square, and taking the square root of all the value, we get square root of 13. And this length is OC is square root of 13. And you see here the radius of circle, we already find this is the radius of circle, and this is 2 unit, and we write it as, and this is the least value of the locus z. So number 4, solve the equation 2 cos x minus cos 1 over 2x equal to 1. Firstly, we suppose that 1 over 2x equal to t. We suppose that let 1 over 2x equal to t. Then x will be equal to 2t. And we substitute the value in this equation. Equation becomes 2 cos 2t minus cos t equal to 1. And we can write this equation 2 cos 2t minus cos t minus 1 equal to 0. Now we have to solve this equation. Now cos 2t, we use the half angle formula, and this formula is given in your formula sheet. The cos 2a is equal to 2 cos square minus 1. We can write this 2 into cos square t minus 1. This is the value of cos 2t, and 2 is written as it is. Minus cos t is written as it is, minus 1. If we simplify it, we get 4 cos square t minus 2 minus cos t minus 1 equal to 0. Now we can write it as 4 cos square t minus cos t minus 3 equal to 0. Now to solve this equation, we factorize the left hand side, and by using midterm breaking rule, now 4 times 3 is 12. The factor will be minus 4 plus 3. Use the factor minus 4 and 3 for the midterm breaking. We write it as 4 cos square t minus 4 cos t plus 3 cos t minus 3 equal to 0. 4 cos t is taken as a common. We get cos t minus 1. And when we take the plus 3 as a common, we get cos t minus 1 equal to 0. Now we can write it as cos t minus 1 into 4 cos t plus 3 equal to 0. Either cos t minus 1 equal to 0 or 4 cos t plus 3 equal to 0. Now we can write it cos t equal to 1 and the t will be equal to cos inverse 1. That's value will be equal to 0 to 2 pi. And same here is we find the value of t. 4 cos t equal to minus 3. The cos t will be equal to minus 3 over 4. For acute value, this angle alpha will be equal to cos inverse minus 3 over 4. Now this value will be equal to 0.723. To find this value t, angle will be negative in the third and fourth quadrant. We can find this value by drawing a quadrant. Now you see here, these are four quadrants, and this value alpha in the second quadrant is negative, and this value alpha in third quadrant negative. Therefore, there are two possibilities of angle t that's equal to pi minus alpha, because the angle in radian we write it pi minus alpha. This is the second option. Alpha plus pi, we write t equal to alpha plus pi. Now this value become alpha is 0.723 and here is t equal to alpha plus 0.723. Now we put the value t equal to 1 over 2x. Therefore, that value become 1 over 2x will be equal to 0 or 1 over 2x equal to 2 pi. Therefore, x will be equal to 0 and here x will be equal to 4 pi. And 4 pi value is out of range value because the x is within the limit 2 pi to 0. Therefore, that value is not possible. Now we put the value t in the second value. You see here x over 1 over 2 equal to pi minus 0.723. Now we can write it x equal to 2 pi minus 1.446, and second is x over 2 equal to pi plus 0.723. Now we can write it as x equal to 2 pi plus 0.723. And this value is also out of range value. No, this is not possible. Now we can write it here as not possible. And this value x equal to 2 pi minus 1.446. And that x equal to 0, and this is the answer. Question 5. The complex number 2 plus yi is denoted by a, where a is real number and y is less than a. It is given that f of a equal to a cube minus a square minus 2a. Find the simplified expression for y f of a in terms of y. Now you see here f of a is equal to a cube minus a square minus 2a, and this expression we simplify it firstly. Now we can write it as a is taken as a common, a square minus a minus 2. You see here we can factorize this, factorize it. Now you see here we can write it a square minus 2a plus a minus 2 equal to 0. Now we can write a into a is a common, a minus 2 plus 1 is a common, a minus 2. Now we get a into a minus 2 into a plus 1. Now we put the value here after solving in this form, it will be easy to solve. Now you see here, a is equal to 2 plus yi, and if we f of a, we replace f of a, the value of a is 2 plus yi. Now we put here 2 plus yi minus 2 and 2 plus yi plus 1. Now you can write it as 2 plus yi into 2 will be cancelled. Now you can write it as yi into 2 plus 1, 3 plus yi. Now we can write it as yi into 2 plus yi into 3 plus yi. Now we multiply 2 to 3 and then 2 to yi, we get 6 plus y is written as it is, and that is into yi into 6 plus 2yi plus 3yi and plus yi into yi plus y square I square. Now we can write this as yi into 6 plus 2 plus 3, 5yi plus y square. I square mean minus 1. Now we can write it as yi into y minus y square plus 5yi plus 6. Now we multiply this yi into yi square, we get y cube I plus 5y square I square, and when yi multiply by 6, we get 6yi. Now I square equal to minus 1, therefore we can write it as 5y square minus I square is written minus 1 and minus y cube I plus 6yi. Now the real value is minus 5y square and the imaginary value will be 6y minus y cube I. And this is the answer. Now we move the next part of this question, part B. You see here, real value of f of a is minus 20, and that is f of a. Now real value is f of a minus 5y square. That's equal to minus 20. Therefore, y square will be equal to minus 20 over minus 5. And y square will be equal to 4, and the y will be equal to plus minus 2. Now you see here the value of y is a real number but is less than 0. Therefore, we write the value y equal to minus 2, and the a complex number become 2 plus yi. That's equal to 2 minus 2i. The argument of a will be equal to inverse y over x. Now tan inverse minus 2 over 2, and that's equal to tan inverse minus 1. Now we make the diagram here, and the diagram of this argument will be in the fourth quadrant, minus 2 minus plus 2 minus 1. This is the point, and this the angle from positive x-axis, this angle will be equal to argument a, and this is value is minus pi over 4. That value is equal to pi over 4, and we take the value, that's value equal to minus pi over 4. We write it tan inverse minus 1 is minus pi over 4, because the argument of z range always minus pi to pi. Question 6. The equation cot x over 2 equal to 3x has one root in the interval x0 to pi and denoted by alpha. Show by calculation alpha lies between 0.5 and 1. Firstly, we make the equation f of x equal to 0. You see here this equation got our 2x equal to 3x. We shift the 3x from right to left side, that become minus 3x equal to 0. The next step, we take the f of alpha value. Now firstly we put the value alpha here is 0.5. Now the f of 0.5, that value become cot 1 over 2 into 0.5 minus 3 into 0.5. We can write this equation 1 over 10 0.25 minus 3 into 1 0.5 is minus 1.5, and this value will be equal to 2.42. Now we find the next value f of alpha, where alpha is 1. We see that f of 1, now put the value in this equation, cot 1 over 2 into 1 minus 3 into 1. This value become 1 over 10, 0.5 minus 3. This value will be equal to 1 divided 0.510, and that is 1.83. 1.83 minus 3, that will be equal to minus 1.17. Now you see here the value of f of 0.5 is greater than 0 and f of 0.1 is less than 0. It shows that if the sign change against these two values, the root will lie between 0.5 to 1. Or B, if a sequence of show that if a sequence of positive value given by iterative formula converge, then it converges to alpha. If this converges to alpha, we have to rearrange this equation in this form, and the result should be cot 1 over 2 x equal to 3x. Now we write this equation as x equal to 1 over 3 into x plus 4 tan inverse into 1 over 3x. Now we rearrange this equation. Now you see here we can write it as 3x equal to x plus 4 tan inverse 1 over 3x, and x shift from right to left side, that become 3x minus x, that's equal to 2x equal to 4 tan inverse 1 over 3x, and when we shift the 4 from right to left side, that become 2x over 4, that's equal to tan inverse 1 over 3x. Now we can write it as x over 2 equal to tan inverse 1 over 3x. We take the tan on both sides, we get tan x over 2 equal to 1 over 3x, and we can write it as, we shift from 3x from right to left side, we get 3x will be equal to 1 over 10 x over 2. 1 over 10 can be written as cot x over 2, and that's 3x will be equal to cot x over 2. We have to prove cot 1 over 2x equal to 3x. Now we move to the next part of this question. Part C, use the iterative formula to calculate alpha. Correct to 2 decimal place, give the result of iteration to 4 decimal place. You see here, this is the iterative formula, and the value of alpha lie between the alpha to alpha 0.1 to 1 because the root lie between these values. Now we can take the first value, the average of 0.5 and 1. Suppose that the value, we take value x1, this value will be the average of 1 and 0.5, that is 0.75. Now the root of this value, it lie where the value repeat itself. If we put the value in this formula and we get the sequence of values, and we can find this x2 value by using this formula. Here is xn plus 1 become x2 and xn will become x1, and this xn also become x1. Now we write this formula according to x2, that will be equal to x2 equal to 1 over 3x1 plus 4 tan inverse 3x1. Now we put the value of x1 in this formula. You see here, that's equal to 1 over 3 into the value of x1 is 0.75. We substitute the value x1 plus 4 tan inverse 1 over 3 time of the value of x1 is 0.75. We find this value that it's equal to 0.8076. And similarly, we take the x3 value, and x3 value we can get by you know that when x3 will be equal to 1 over 3 x2 plus 4 into tan inverse 1 over 3x2. Now we put the value here. X2 is 0.8076. You see here, and plus 4 into tan inverse 1 over 3 to 0.8076. Now when we calculate it, we get 0.7911. The next value, x4, x5, and x6, we can calculate it by substituting the value in this formula. We get 0.7954 x4 value, and x5 is 0.7942. You see here, we have to take the value 4 decimal place, and now we see that the value where it repeats, we take 2 decimal place value. Now we approximate 8.076, that value becomes 0.81, and this value becomes 0.79, and next value becomes, we write it as 0.80, and that is 0.79. Next is, you see here, that is 0.79, and that value repeat itself. Therefore, value of this alpha will be equal to 0.79, and 0.79 is the answer. We write it here. Question 7, the equation of curve is 3x square plus 4xy plus 3y square equal to 5. Show that dy over dx equal to minus 3x plus 2y over 2x plus 3y. You see here, this is the equation, and 3x square plus 4xy plus 3y square equal to 5. Firstly, we take the derivative on d over dx on both sides. Now we write it as d over dx on left side and d over dx on right side. Now you see here the derivative of 3x square, 3 is written as it is. The derivative of x square, we use the formula x power n, that's equal to nx power n minus 1. That value becomes 2x power 1. And same here is 4xy. The derivative of xy, we use the product rule here. Firstly, we write the second function is written as it is, and the derivative of first function, the derivative of d over dx of x plus first function is written as it is, and the derivative of second function. And next is we take the derivative of y square, 3 is written as it is, and the derivative of y square dy over dx we write here, and that's equal to d over dx of constant is 0. We get 6x plus 4 into y, and dx over dx, the derivative is 1. We write it as plus x into dy over dx written as it is. And next is plus 3 into a derivative of y square. We use this formula. Firstly, we take the power rule. Now n into f of x power n minus 1. That's become 2 into y power 2 minus 1. And then we take the derivative again d over dx of base. Base is y. And we write it here as, now we can write this 6x plus 4y plus 4x dy over dx plus 6y into dy over dx equal to 0. Now we write it here as 6x plus 4y. We shift from these values from left to right side. That becomes 6x minus 4y minus 6x minus 4y. And these two terms having a common dy over dx, we take a common. The remaining values 4x plus 6y. And we can write this value dy over dx will be equal to minus 6x minus 4y over this value shift from left to right side. That become 4x plus 6y. Now we take the common minus 2. That's become 3x plus 2y. And same here is we take a common 2. That's become 2x plus 3y. Now 2 will be cancelled. Dy over dx will become 3x plus 2y over 2x plus 3y. And we have to prove the dy over dx is equal to this value. And find the exact coordinate of 2 points of the curve at which the tangent is parallel to the line y plus 2x equal to 0. You see here, this is the equation of the curve and this is the value of dy over dx. And dy over dx, it shows the gradient of the tangent at the curve. And we suppose that the gradient of the tangent of the curve, we name it as m, and that will be equal to minus 3x plus 2y over 2x plus 3y. Now this tangent line is parallel to the line y plus 2x equal to 0, and therefore the y equal to minus 2x. When we compare this equation y equal to mx plus c, this m shows that the gradient of the tangent. Now this gradient of the tangent m equal to minus 2, and this line is parallel to the tangent. Therefore, these gradient will be equal. We put the value here, m equal to minus 2 minus 3x plus 2y over 2x plus 3y. Now we can write it as 2 into 2x plus 3y. That value becomes 4x plus 6y. This equal to 3x plus 2y. Now 3x shift from right to left side. That becomes 4x minus 3x. And that's equal to 2y minus 6y. And we can write it x minus 4y. And this value, we put the value in this equation. And this equation is 3x squared plus 4xy. We write here 3x squared plus 4xy plus 3y squared equal to 5. Now we put the value x in this equation. We get 3 into minus 4y whole square plus 4 into x into 4 into minus 4y, and y is written as it is plus 3y squared equal to 5. 48y squared, 4 for the 16 minus 16y squared plus 3y squared equal to 5. Now we write it 48 plus 3, 51 minus 16. That is equal to 35y squared equal to 5. Then y square equal to 5 over 35. And this value becomes y square will be equal to 1 over 7, then y will be equal to square root of 1 over 7 plus minus. Now, after getting the y coordinate, we have to find the x coordinate value. We substitute this value y in this equation 1. Now, for x, y equal to 1 over square root of 7 and y equal to minus 1 over square root of 7. Now the x will be equal to minus 4y. Therefore, minus 4 into 1 over square root of 7, and that x will be equal to minus 4 over square root of 7. And same here is x equal to minus 4y, then x equal to minus 4 into the value of y coordinate is minus 1 over 7. Therefore, this value will be equal to 4 over square root of 7. Now the point coordinates of the point will be x is minus 4 over square root 7. The value of y is 1 over square root of 7. And x equal to, here is the x is 4 over square root 7 and y coordinate is 1 minus 1 over square root 7. And these are the 2 points on the curve at which tangent is parallel to y plus 2x equal to 0. Question number 8, the variable x and y satisfy the differential equation dy over dx equal to 4 plus 9y square over e power 2x plus 1. It is given y equal to 0, x equal to 1. Solve the differential equation. You see here, this is the differential equation. We arrange this in this differential equation. Now we shift the 4 plus 9y square from right to left side. That become dy over 4 plus 9y square. Because now same here is we shift the dx from left to right side. That's become dx over a power 2x plus 1. Now, to solve the differential equation, we take the integral on both sides. Now, after taking integral, you see here, we can write this equation as dy over 2 can be written as 2 whole square plus 3y whole square integral, and that's equal to integral dx. Now you see here the power e power 2x plus 1, we shift from denominator to numerator. That's power become negative e into 2x plus e power minus 2 into 2x plus 1 into dx. And you can see here, this is the formula we will use to solve this equation, 1 over a square plus x square. The formula is given in your formula sheet. That's equal to 1 over a tan inverse x over a into 1 over dx or d over dx of the derivative of angle. Now you see here the this expression is not given in your formula because the derivative of x is 1. Therefore, there is not mentioned this 1 over d over dx of x. But now you can write it as 1 over a is 2 into tan inverse x over a, x is 3y, a is 2, and then 1 over derivative of 3y. You see here, the derivative of 3y will be equal to 1 over 3 into equal to, we take the integration of this e power minus 2x plus 1. You see here, that is e power ax, our derivative of the power value. You see here, we can write e power minus 2x plus 1. Our derivative of minus 2x plus 1 is minus 2, and we write the plus constant. Now we can write this 1 over 6 into tan inverse 3y over 2 equal to minus 1 over 2 1 over e power 2x plus 1 plus c. Now to find the value of c, we can find this value. We substitute the value y0 and x equal to 1, y0 and x equal to 1. we get 1 over 6 into tan inverse 0 equal to minus 1 over 2 into 1 over e power 2 into 1 plus 1 plus c. Now tan inverse 0 is 0. Now minus 1 over 2 into e power 2 into 2 plus 1. 2 plus 1 is 3. 1 over e power 3. Therefore, the value of c is minus 1 over 2 e power 3. Shift from right to left side, that becomes positive 1 over 2 e power 3. Now we substitute the value in this equation 1. Now that equation become 1 over 6 into tan inverse 3y over 2 minus 1 over 2 e power 2x plus 1 plus 1 over 2 e power 3. Now we take the common 1 over 2 on both sides. We can write it as 1 over 2 into 1 over 3 tan inverse 3y over 2 and 1 minus 1 over e power 2x plus 1 plus 1 over e power 3. 1 over 2 will be cancelled. And this is the differential equation we get. Now we can write it as 3 into minus e power minus 2x plus 1. Now we shift the 3 from right to left side, that become tan inverse 3y over 2. That's equal to 3 into minus e power minus 2x plus 1 plus e power minus 3. Taking tan on both sides, we get 3y over 2 and tan into 3 e power minus 3 minus 3 into e power minus 2x minus y. Now y will be equal to 2 over 3 into tan 3 e power minus 3 minus 3 into e power minus 2x minus 1. And this is the differential equation we have to find. Part B, state what happened to the value of y. X tends to infinity. Give your answer in exact form. You see here, this is the equation, differential equation, y equal to 2 over 3 tan e 3 into e power minus 3 minus 3 e power minus 2x minus 1. Now, to make the power positive, we shift from numerator to denominator. The power becomes positive. You see here, we can write tan into 3 over e power 3 minus 3 over e power 2x plus 1. Now we take x tends to infinity. We can write it as here 2 over 3 a tan into 2 over 2 power 2 over e power 3 minus 3 over e power infinity. That will be equal to 2 over 3 tan into 2 over e power 3 minus 3 over infinity is 1 over infinity, you know, is 0. You can write it 0. Therefore, 2 over 3 tan into 2 into e power minus 3, the value of y will be when x tends to infinity. Question number 9, let f of x equal to 2 into x square plus 17x minus 17 over 1 plus 2x into 2 minus x whole square express f of x in partial fraction. You see here, this fraction is a proper fraction because the numerator is less than the denominator, because the degree of numerator is 2 and the degree of denominator expression is 3. Therefore, this is the proper fraction. After checking this, we resolve this fraction into 2 or more than 2 fraction. You see here, the denominator is 1 plus 2x into 2 minus x whole square. Firstly, we write the first fraction of denominator 1 plus 2x, and second fraction of the denominator will be 2 minus x, And third fraction, the denominator will be 2 minus x whole square. Now we write the numerator. The first numerator will be a, second numerator will be b, and third numerator will be c. And we name it this equation and equation 1. Now we multiply this equation by 1 plus 2x into 2 minus x whole square. We write it here, multiplying. Now therefore, this equation becomes 2x square plus 17x minus 17 equal to, when we'll multiply this fraction by 1 plus 2x into 2 minus x whole square, 1 plus 2x will be cancelled. We get a into 2 minus x whole square plus b into, when we multiply b over 2 minus x with 1 plus 2x into 2 minus x whole square, we get 1 plus 2x into 2 minus x, c into 1 plus 2x, and we substitute the value 1 plus 2x equal to 0. Now we get x equal to minus 1 over 2, and we get 2 into minus 1 over 2 whole square plus 17 into minus 1 over 2 minus 17 equal to a into 2 minus 1 over 2 whole square plus b into 1 plus 2 into minus 1 over 2, 2 minus 1 over 2 plus c into 1 plus 2 into minus 1 over 2. Now we can write it as 2 into 1 over 4 is 0.5 plus 17 into minus 1.1 over 2 is minus 8.5 and minus 17, and that value become minus 25. And same here is, we can write it 2 plus 1 over 2, that's equal to 5 over 2 whole square plus b into, and you see here 2 will be cancelled, and this 2 will also be cancelled. We get 1 minus 1 is 0. Now we can write it as b into 0 plus c into 0. Now that's value equal to 25 over 4, and we can write it as a equal to minus 25 over 4 over 25, and therefore the value of a will be equal to minus 4. Now to find value of b, we write this equation number 2 is written as it is. Now to find b, comparing the coefficient of x square, you see here the coefficient of x square and left side is 2. Here is the coefficient is a, plus here is the coefficient is minus 2b, a minus 2b equal to 2. You know a is equal to minus 4. This is the minus 4. Now we write it here, minus 4 minus 2b equal to 2. You can minus 2b will be equal to 6, because when we shift minus 4 from left to right side, it becomes positive. Now that's b will be equal to 6 over minus 2 is b equal to minus 3. The value of b is minus 3, and the value of a we already find is minus 4, and the value of c is equal to 5. We put the value in this equation 1. This is the equation 1. We put the value in this equation. We get 2x squared plus 17x minus 70 over 1 plus 2x into 2 minus x whole square equal to a over a is minus 4 our 1 plus 2x plus b is minus 3 over 2 minus x plus c is 5 over 2 minus x whole square, and this is the partial fraction form of the function, and this is the answer. Question 9 part B, hence show that integral 0 to 1 f of x dx equal to 5 over 2 minus ln 72. Now you see here the left hand side of this equation is 0 to 1 f of x dx. Firstly, we write the left hand side. Now 0 to 1 integral, and the f of x value you see here minus 4 over 1 plus 2x minus 3 over 2 minus x plus 5 over 2 minus x whole square and into dx. Now we take the integration. Now minus 4 into integral 0 to 1 dx over 2x plus 1, 3 into integral 0 to 1 dx over minus x plus 2, integral 0 to 1 into 2 minus x power minus x 2 minus 2 into dx. Now we start the integration. Now the integration of 1 over x plus a is equal to ln x plus a, our derivative of this x plus a. Now you see here we can write it as minus 4 into ln 2x plus 1. Our derivative of 2x plus 1 is 2 minus 3 into ln minus x plus 2. Our derivative of minus x plus 2 is minus 1 plus 5 into, use the power rule, that's become 2 minus x power minus 2 plus 1 divided by minus 2 plus 1 into 1 over derivative of 2 minus x. The derivative of 2 minus x is minus 1. We apply the limits. The limits of all these terms is 0 to 1. Therefore, we write the upper and lower limits value. Now, we can write it as minus 2 into ln 2x plus 1 plus 3 into ln minus x plus 2, and minus plus minus 1 into minus 1 plus 1, that's 5 to 2 minus x power minus 1, and apply the limit 0 to 1. Now we put x equal to 1 here. We get minus 2 into ln 2 into 1 is 2 plus 1 plus 3 into ln minus 1 plus 2 plus 5 into 2 minus 1 power minus 1 and minus, and we apply the limit 0, minus 2 into ln 0 plus 1 plus 3 into ln 0 plus 2 plus 5 into 2 minus 0 power minus 1. Now we simplify it. Minus 2 into ln 1 plus 3 into ln 1, 2 plus 1 ln, minus 2 into ln 3 plus 3 into ln 1 plus 5 into 1 power minus 1 is 5. Now minus plus 2 into ln 1 minus plus minus 3 into ln 2 minus plus minus 5 into 5 over 2 power 1 is 2. Now we can write it as minus ln 3 power 2 plus 3 into ln 1 is 0 plus 5 into 2 into ln 1 is 0 minus ln 2 power 3. Now the coefficient of ln become the power of this ln value. Now we can write it as minus ln, minus is taken in common, ln 3 square plus ln 2 square, 2 cube, plus 5 minus 5 over 2. Now we get plus 5 over 2, and that's equal to ln 3 square is 9 plus 8, ln 8. Now we can write it's minus ln 9 in plus ln 8. We use the product rule, ln 9 multiplied by 8 plus 5 over 2. Therefore, the answer will be equal to 5 over 2 minus ln 70. 9 8s are 72. This is the answer. Question number 10. The diagram shows the curve y equal to x plus 5 into square root of 3 minus 2x, and in maximum point m, find the exact coordinate of m. You see here, this is the equation of the curve y equal to x plus 5 into 3 minus 2x power 1 over 2. We write it as this equation. To find the maximum point, you see here, this is the maximum point m. The gradient of tangent at this point will be 0. To find the gradient of tangent of the curve, we take the derivative of dy over dx of this equation, and that dy over dx equal to 0. Firstly, we take the derivative on both sides, and left side dy over dx, and also right side d over dx. We get x plus 5 into 3 minus 2x power 1 over 2. Now we apply the product rule for derivative d over dx of u into v, that's equal to u dash into v plus u into v dash. V dash means the derivative of this function. Now we take the derivative of first function is x plus 5. X derivative of x is 1 plus 0, and second function is written as it is, and plus first function is written as it is, and derivative of this function, that's equal to 1 over 2 into 3 minus 2x, and we subtract 1 from the power of 1 over 2, 1 over 2 minus 1, the power become coefficient, and next is the derivative of this base, 3 minus 2x, the derivative of 3 is 0, minus 2x is 2 into 1. Now we can write it as 3 minus 2x power 1 over 2 plus, and we can write it as minus 2 into 2, 2 will be cancelled, minus 1, we can write as minus 1 into x plus minus 1 x plus 5 into minus 3 minus 2 over x, we can write it as 1 over 3 minus 2x power 1 over 2. That's equal to 0. Minus x power plus 5 over 3 minus 2x, from right to left side, we can write x plus 5 over 3 minus 2x square root, that's equal to 3 minus 2x square root. Now we cross multiply, we get x plus 5 equal to 3 minus 2x square root into 3 minus 2x square root, that become 3 minus 2x. You can write x minus 2x. Minus 2x shift from right to left side, that become x plus 2x equal to 3 minus 5, and x will be equal to 3x will be equal to minus 2, and x will be equal to minus 2 over 3, and the coordinate of this m will be minus 2 over 3. To find the value of y, find the coordinate of y, we'll substitute the value of x in this equation. Now put this value here. Now we can write a y equal to x plus 5 into 3 minus 2x square root, and we put the value x equal to 2 over 3 minus 2 over 3 plus 5 into square root of 3 minus 2 into minus 2 over 3. Now we can write it as minus 2 over 3 plus 5. That's become 13 over 3 into 3 minus plus 3 plus 4 over 3 square root. And we can write here is 13 over 3 into square root of 13 over 3. Therefore, we can write it as 13 over 3 power 1 plus 1 over 2. And therefore, the answer will be 13 over 3 power 3 over 2. This is the coordinate of y, and the coordinate of x is minus 2 over 3, and the coordinate of y is 13 over 3 power 3 over 2. And this is the coordinate of the maximum point M. Question 9, using substitution u equal to 3 minus 2x, find by integration the area of shaded region bounded by the curve and the x-axis. Give your answer in the form of a of square root of 13. You see here, this is the curve, and we have to find the area between the curve and the x-axis. You know the area of the curve and a line x equal to a and x equal to b. It means the area of the curve and the x-axis. And these points x equal to a and b, where the curve intersects the x-axis. Now to find these points a and b, we take the value y equal to 0. Now you see here, we write it here. To find a and b, we take y equal to 0. When we put x plus 5 into 3 square root of 3 minus 2x equal to 0, we get x plus 5 equal to 0, and 3 minus square root of 3 minus 2x equal to 0, and we can write it x equal to minus 5, and that's 3 minus, we take square on both sides, we get 3 minus 2x equal to 0, x equal to 3 over 2, value become 1.5. And these are the values where the curve intersects the x-axis. This is minus 5 and this value is 1.5. Now we have to integrate to find the area. We use the substitution method. Therefore, the area of shaded region, we have to find a, b, f of x dx. You see here, the value of a is minus 5, b is 1.5, and then x plus 5. The function is x plus 5 into 3 minus 2x. We use the substitution method. U here is given u equal to 3 minus 2x. We put u equal to 3 minus 2x. And this x will be equal to, then x will be equal to 3 minus u over 2. And then we have to find du over dx. You see here, when you take the derivative du over dx, that value becomes 0 minus 2 dx. Therefore, we can write dx will be equal to du over minus 2, and this is the value of dx. Now to find the value of u against these limits, minus 5 and 1.5, now we put the value here. Now you see here x equal to minus 5, we put in the equation u equal to 3 minus 2x, we get u 3 minus 2 into minus 5, and that value become 3 minus 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 plus 5 to the 10, 3 plus 10 is 13. And same here is when we take the value x equal to 1.5, then u equal to 3 minus 2x, and 3 minus 2 into 1.5, we write it 3 minus 2 into 1.5 is 3, that value become u equal to 0. Now we put the value in the integral equation. You see here, this is this value u is minus 5, the value of u, value of x is minus 5, u is 13, we write 13. And when x is equal to 1.5, you see here, this is x equal to 1.5. The value of u is 0. Therefore, we write 0, 13. And the function is become x plus 5. You see here the x is 3 minus u over 2 plus 5, and 3 minus 2x is considered as u. Now square root of u it becomes, and dx, you see here the dx value is du over minus 2. Now write this value minus 1 over 2 into 0 into 13. Now we can write this 3 over 2 minus u over 2 plus 5, and we can write the square root of u is u power 1 over 2 du. Now we multiply 3 over 2 plus 5 is 13 over 2. You can do it here. 3 over 2 plus 5, that's equal to 3 plus 10, and that's equal to 13 over 2. We write here minus u over 2 and 2 power 1 over 2 into du. Now you see here the minus 1 over 2 become plus sign. The limits of the integral will be interchanged. The upper limits becomes lower and lower limits become upper. Therefore, you see here we write it 13 0 becomes 0 13. Now we write this value 1 over 3 into 0 to 13, and 13 we take the integration, or we multiply this u power 1 over 2. That becomes 13 over 2 into u power 1 over 2, and u into u power 1 over 2, its value becomes u power 1 plus 1 over 2 is 3 over 2. We write here u power 3 over 2 minus 2 into d. And next is we write here 1 over 2 into 13 over 2. We take the integration u power 1 over 2. The integration we use the power rule. U power 1 over 2 plus 1 divided by 1 over 2 plus 1. And same here, u power 3 over 2, we write 1 over 2 as it is, and u power 3 over 2 integration is 3 over 2 plus 1 and divided by 3 over 2 plus 1. Now you see here, we can write here is 1 over 2 as it is, and 13 over 1 over 2 plus 1, that's equal to 3 over 2. Now we write here is 3 over 2, 2 will be cancelled, and 1 over 2 is written as it is, u power 3 over 2 plus 1, you know, that becomes 5 over 2, and 3 over 2 plus 1 is 5 over 2, 2 will be cancelled. You see here that the area of triangle become 1 over 2, this value is 1 over 2, and 13 over 3. You see here 13 over 3, we write here 13 over 3, u power is 3 over 2. We apply the limit here, u is 13, we write 13 power 3 over 2 minus 1 over 5, we write as it is. And we put the upper limits here, u value is 13, so then become 13 power 5 over 2 minus, now we put the value 0 in this function. You see here, if we put here is 0, then 0 minus 0, the whole value becomes 0. I write here is 0. Now next is the 1 over 2 is written as it is, and 13 power 3 over 2 is taken as a common. You see here, I write down this value in red color. Now you see here 13 power 3 over 2 is taken as a common, 13 over 3 is written as it is, and minus is written as it is, 1 over 5 is written as it is, 13 power 5 over 2 when we take a common. Therefore, 13 power 1 into 13 power 1 over 2. Therefore, we write is 13 into square root of 13. And 13 over 3 minus 13 over 5 is written as it is. Now, you see here 1 over 2 is written as it is, 13 is written as it is, and square root of 13 is written as it is. Now, 13 over 3 minus 13 over 5, we take the LCM 15. There's 3 times 5 is 15. We multiply 5 by 13, we get 65, and 15 divided by 5, we get 3. We multiply it by 3. We get 65 minus 39. So 1 over 2 into 13 into, you see here 65 minus 39 is 26. We write here is 26 over 5 and multiply square root of 13 is written as it is. Now we divide this 2 ones are 2. 2 times 13 is 26. Now, next part, you see here, we can write 13 times 13 is 169 over 5 multiply by square root 15. Now we compare it with the 169 or 5 square root of 13 with a square root of 13. You see here, we get a will be equal to 169 over 5. This is the answer. Question 11, the points A and B have position vector I plus 2j minus 2k and 2i minus j plus k. The line has r equal to I minus j plus 3k plus mu into 2i minus I minus 3j plus 4k. Show that L does not intersect the line passing through A and B. Firstly, we find the equation of line passing through A and B. We use the 2-point form equation of line. Vector equation of line. You see here, this is the equation of line passing through A and B, r equal to OA plus lambda AB. Now AB can be written as OB minus OA. Therefore, we write r equal to OA plus lambda OB minus OA. Now we put the value of OA. OA is 1 plus 2j minus 2k, and we the coordinates of this points 1, 2, minus 2, and the coordinates of point B will be 2, minus 1, 1. Now we write the this equation of line in column form. You see here, in the column form, this line can be written as r equal to OA is 1, 2, minus 2. We write 1, 2, minus 2, and lambda is written as it is. Now the OB the coordinates of B 2, minus 1, 1. We write 2, minus 1, minus 1. And now you see here the coordinates of OB is 2, minus 1, 1, 2, minus 1, 1. And minus OA, or the coordinate of A is 1, 2, minus 2, 1, 2, and this is the minus 2. Now, if we write the equation in parametric form, then x will be equal to 1 plus 2 minus 1 is 1 lambda, and y will be equal to 2 plus minus 1 minus 3 lambda, and z will be equal to minus 2 plus 1 plus 2 is 3 lambda. Now we write the second equation. This is the equation of line L. We write this equation in the column vector form. You see here, this is the x, y, z. We can write instead of r, x, y, z, and the this vector in column form 1, minus 1, 3, and mu is written as it is. And this is the column vector of 2i minus 3j plus 4k. Now we write in the parametric form, the x will be equal to 1 plus 2 mu, and y will be equal to minus 1 plus 3 minus 3 mu, and z will be equal to 3 plus 4 mu, and we write 3 plus 4 mu. And you see here, there are two values of x. One is 1 plus 1 lambda, other is x equal to 1 plus 2 mu. Now, if these two equations intersect to each other, we compare these two equations, we get 1 plus 1 lambda equal to 1 plus 2 mu, and 2 minus 3 lambda will be equal to minus 1 minus 3 mu, and minus 2 plus 3 lambda will be equal to 3 plus 4 mu. And this equation 1 plus lambda equal to 1 plus 2 mu can be written as, you see here, we can write it as lambda equal to 2 mu will be shifted from right to left side, that become lambda minus 2 mu, and 1 will be cancelled. We can write lambda minus 2 mu. Now next is the equation 2 minus 3 lambda equal to minus 1 minus 3 mu. We shift the mu from right to left side, that become this equation become minus 3 lambda minus plus 3 mu, because it become minus 2 positive, and minus 1 minus 2 become minus 3. And the last equation you see here, 3 lambda. Now we shift the 4 mu from right to left side, it becomes 3 lambda minus 4 mu equal to 5. Next, now we have to find the value of lambda and mu. We take any two equations to find the value of mu and lambda. After getting this value, we put the value in the third equation. You see here, if we take equation 2 and 3, it will be easy to find the value. Adding equation 2 and 3, we get minus 3 lambda plus 3 lambda plus 3 mu minus 4 mu equal to minus 3 plus 5. We get minus 3 lambda plus 3 lambda will be cancelled. And the next 3 mu minus 4 mu, that will be equal to minus mu, and minus 3 plus 2, 5 equal to 2. Now we write as mu equal to minus 2. Now next value can be obtained by substituting this value in the equation 2. You should remember we are solving these two equations. You have to put the value in any of these two equations to find the value of other variable. Now you see here, to find the value lambda, we put in the equation 2. We get minus 3 lambda plus 3 into minus value of mu is minus 2. We put in this equation, that become 3 into minus 2 equal to minus 3. Now therefore we get minus 3 lambda minus plus 3 minus 2 is minus 6 equal to minus 3, and that minus 3 lambda will be equal to minus 6 plus 6 minus 3, because when we shift the value from left to right side, it become minus 3 plus 6, we get 3, and lambda become equal to minus 1. Now we get the value mu and lambda is minus 2 and minus 1. Now we put this value in the third equation to see these two lines are intersecting or not. Now you see here, if we substitute the value lambda and mu in this equation 1, now the value become minus 1 minus 2 into mu value is minus 2, lambda value. Now the value of lambda is minus 1 minus 2 into mu value is minus 2. Now we get minus 1 plus 5 equal to 0. That's 4 is, it does not equal to 0. We write here that is therefore the value of mu and lambda do not satisfy the equation 1. Therefore we can say that the line L and the line passing through A and B do not intersect, because mu and lambda value do not satisfy the equation. Question 11, B part, find the position vector of the foot of perpendicular from A to L. Firstly, we draw the line L. You see here, we draw a line L. This is the red line shows that this is the line L. Take a point A, and we draw a perpendicular from A to L. You see here, this is the perpendicular and it intersects the point at C. The point of A, you see here, this is the coordinates of point A, 1, 2, minus 2, and we mention here. Now the equation of line L is equal to I minus j plus 3k plus mu 2i minus 3j plus 4k. Now the parametric form of this equation of line we mention here. You see here, this is the parametric form of this equation of line L. Now you see here, from this parametric form, we write the coordinates of this the point C. The coordinates of point C, it would be 1 plus 2 mu into minus 1 minus 3 mu and 3 plus 4 mu. And these are the coordinates. Now we find the vector AC. You see here, the AC will be equal to OC minus OA. We can write this equation as taking the difference between OC minus OA, the OC vector. The coordinates of OC are here 1 plus 2 mu minus 1 minus 3 mu, 3 plus 4 mu, and OA is 1, 2, minus 2, and we write here. Now you see here, 1 plus 2 mu minus 1, that same here is minus 1, minus 3 mu minus 2, 3 plus 4 mu minus 2. 1 plus 1 minus 1 will be cancelled, and that's we get 2 mu, and minus 1 minus 2 is minus 3, minus 3 mu minus 3. 3 minus 2 plus 2, and therefore 3 plus 2 is 5, 4 mu plus 5, and this is the vector equation of AC. Now you see here the line AC and line L are perpendicular to each other. Therefore, the vector AC and the direction vector of line L will be, and the dot product between AC dot AB will be equal to 0. Now we write the vector AC here, a column in the column vector form: 2 mu minus 3 mu minus 3, 4 mu plus 5. And the vector B, you see here, the position vector of B is 2i minus 3j plus 4k. We write in the column form 2 minus 3 and 4. Now we multiplied it, we get the 2 mu multiply 2, we get 4 mu minus 3 mu minus 3. We multiply by minus 3, we get 9 mu plus 9. And 4 multiplied by 4 mu plus 5, we get 16 plus 20, that's equal to 0. Now we add 4 mu plus 16 mu, that's equal to 29 mu, and 20 plus 9 equal to minus 29. Now we find the value of mu. You see here the value of mu will be equal to 29 mu minus 29 mu will be equal to minus 1. Now we put the value in the parametric form of the line L. We get the point C. Now you see here the to find this value, x equal to 1 plus 2 mu, then 1 plus 2 into mu is minus 1. We put here is minus 1. Now we get minus 1. Same here is y equal to minus 1 minus 3 mu, minus 1 minus 3 mu, then equal to minus 1. Minus 3 into mu value is minus 1. We put here, then become minus 1 plus 3, that's equal to 2. And same here is z equal to 3 plus 4 into minus 1. That value become 3 minus 4 equal to minus 1. Now the position vector of the point C will be equal to OC. The coordinates of C are 1, 2, and minus 1. Therefore, the position vector of the foot of the perpendicular will be OC equal to minus 1 plus 2i minus k, and we have to find this position vector of the foot of perpendicular, and this is the solution.